Hi everyone, welcome to the GUAC maintenance meeting. The meeting is being recorded, will be uploaded, as well as compliance to the LF and OpenSSF Code of Conduct and antitrust policies. Cool. So looks like we have a pretty full call today. Do any folks wanna introduce themselves or reintroduce themselves? Yeah, DJ.
I don't want to introduce. I'll let James introduce himself, but I was just want to say, James is here from the Plastify team, and if we have time today to talk about the V2 plans and everything, I thought it would be a very good idea to talk about the graph in the graph thingy in Trustify, and yeah, James is most competent to talk about it, so I asked him to join us.
Awesome. Brent?
James, your audio is not working, I think.
Test, test, test. That works. Great. James Fuller, Principal Engineer at Red Hat Product Security, building all these kinds of software stuff. And yeah, I've been sort of seconded to this team from Product Security for the past 6 months. Yeah, there might. I mean, everyone seems to gravitate towards the same kind of solutions across the industry. So I might tell you the problems I have that are the same problems you guys have.
Awesome. Good to meet you, James.
Yeah, and then I'm Brant. I hopped on a few of the community calls towards the end of the year last year and beginning of this year, revisiting the same topic with some renewed vigor. So that I join and say hello, and if we have time, discuss more OpenSSF project integrations.
And this is revisiting the AgApp stuff, right?
Yes, I think that's fair.
Awesome. I guess hi Eddie. Good to see you here.
Oh.
Well,
So I guess we have. Sorry.
I was gonna say, I know Eddie's trying to eat real quick, but I asked him to come here this week to talk to us. He's been apparently working on some tooling for automating evaluation of projects against the open source project security baseline that he and I are both maintainers on. So I thought I'd let him come explain some of that so we can start doing that work as part of the pilot project. And stuff like that. I'll just wait till he's no longer chewing. Hey,
Awesome.
okay.
Yeah, I think we do have quite a few topics today, so let's figure out how much time folks are thinking about each topic, and then let's figure out how to approach this.
Well, if you want to take me off the hook, I can just tell you that right now I'm still working on a Serif results format, so that way when we run the tests, it can actually connect to the security tab inside GitHub. So because that's pending, I don't want to show you I mean, I could show you just like the YAML kind of outputs, but basically the thing that Ben was talking about is CI tool, run it, get a bunch of truesies and falsies, tell you what to fix. And as soon as it's ready, it should just be a few lines to drop in a CI file. I'm hoping it's this week. But all the tests are pretty cool. It's just a bunch of trues and falses, and it should enable everybody to streamline a lot of those improvements. And that's it. That's everything that Ben asked me to tell you guys.
Awesome. Ben, what kind of what you were thinking that this is additional information that we can get from the repositories or something
Yeah,
else?
so this is basically, the idea of we wanted to use GUAC as a pilot project for the baseline to see like, is it useful as project maintainers to be able, to evaluate ourselves against this, and also like, what level of baseline does GUAC hit right now? Hopefully at least we hit all of the level 1. I'm sure we probably need at least some of the level 2 and level 3, but probably not all of them. But as the baseline matures and gets broader adoption, I think we can expect eventually Linux Foundation projects and all of the various sub foundations will be expecting their projects to meet an appropriate baseline level based on where they are in the project lifecycle. So it's kind of a way for us to get ahead of some of that as well.
Awesome. Do we don't have an issue open for this yet, right?
No, we don't.
Okay. Okay, let's create one, and then maybe we'll see how. At least I think like evaluating the baseline, that should be pretty straightforward. CI integration.
I guess the question I have is, do we want to open it in the GUAC repo and sort of treat like the GUAC repo as the one we care about? Or do we want to evaluate this against also against like GUAC Visualizer and the ID tags repos and the sort of like everything under the GUACsec ecosystem?
I would say GUAC itself,
Okay.
not the others, right? Because other ones are more experimental and so.
All right, works for me.
Yeah, I think once we have the issue open, I think we can discuss like integration into GUAC, like how do we store the data and whatever else, right? So
Okay, or maybe someone from the community wants to pick that up. So it's a nice, good first issue. Awesome. Okay, I think the chat about the graph and the ontology v2 stuff is gonna probably expand till the end of time. So, so Brent, I'm wondering maybe we can hop to your topic. Do you think it's reasonable to kind of like a 15 minutes discussion is reasonable? And then we'll see whether we need longer, and then we can revisit it.
I think for the discussions that I had today, they were like pretty brief, to be honest. I think that like the air gap considerations should flow into V2 discussions, and I think I'm more going to try to like just try to gain context as we go there. But I think really my whole topic of discussion was I dropped a blurb out in the GUAC Slack channel. Saw a few people saw it, which is awesome. And basically, from the discussions we had at the end of last year, I'm a maintainer for a project called Zarf, also an OpenSSF sandbox project. And I thought it would be really neat to tell a kind of like integrations lifecycle story of Zarf is meant to like establish this continuous software delivery to connected or disconnected environments. And we do a little bit of like, hey, let's grab images, let's create the SBOMs for them. And so we have the SBOMs sitting there, and that's awesome. And so we do deployments of applications. Cool. It really feels like there's this natural link somewhere in there where if like my environment had GUAC deployed, that Zarf is already grabbing everything and taking them to this environment. like let's just deliver the SBOM somewhere and try to establish a very natural like integration where in some way GUAC could say, hey, I see that there are new SBOMs being published to this location. And so I don't think it needs to be a fully refined, gold-plated solution. But I think OpenSSF Community Days was like, oh, interesting. We have a couple months leading up to that. Is there, a spin on this of saying, here's these two projects working together, and what would it look like? Is there things to learn from it? Because I think, yes, there are things that Zarf should change about its SBOM operations, and I'd love to like learn through that experience as well as, potentially feed GUAC kind of like SBOM delivery discussions, if you will. So I don't think that I have too much. I'd love questions if people have them. Otherwise, uh, same that message sitting on the channel. If somebody wanted to kind of partner on a joint CFP submission before the March 23rd deadline, I believe. I'd love to toss some ideas back and forth.
Yeah, I remember us chatting about this. And I think that one of the use cases that they came out was kind of just like running GUAC and just having it point to a folder within the Zoff environment and just dumping SBOMs there. And that way you can just like query like what's running within this Zoff context, right? Which I think should be actually pretty straightforward for us to implement.
Yeah, I think this also goes into the taking GUAC into the air gapped, right? How do you keep it up to date and right and running and all that kind of stuff? So I think it'd be doing that initially, and then okay, then how do we keep updating the information within the air gapped environment?
Yeah, so I think there's some pretty tall order like magnitude items that probably like should hopefully flow into V2 a little bit. And again, that's me projecting here.
Mhm.
And I think that's totally fair. This I wanted to really just emphasize does not need to be like this is the concrete defined like air gap strategy for GUAC. I think it's really just to like try to set the stage and see if there's like threads to pull on, throughout development, right? And say, okay, yes, we've crossed this first hurdle of an initial, here's a one statement of value that GUAC can provide in an air gap, scenario. How do we then start to bridge, trying to feed data and seed data into these environments and do all those other things that are much more complex with regards to like all of the pathways. So I think there's a lot of opportunity, and didn't want to like back us into a corner where it needs to be the fully refined deliverable. But I think kind of just trying to find a way to like figure out what things are most valuable to the discussion by doing rather than trying to guess. And so I think by maybe just going through a reference deployment, we can say, here are the things that require the connection. Let's make note of them. Here are the things that don't. And these will work out of the box. And then here's where, maybe there's room to optimize these deployment scenarios. So I don't think I really need much else. Again, I'd love to continue the discussion, but if I think from the CFP thing, if there is anybody interested, just reach out to me on Slack. More than willing to continue the discussion or continue that thread in the GUAC channel.
Awesome, sounds good. I think even if you, I think even if no one like is able to do the CFP and attend the conference, we are still happy to like help out with like what needs to be like what are the considerations and helping it be deployed as well.
Absolutely.
Thanks, man. All right. Let's talk about graphs.
Well, there's a lot to talk about. I don't know. Has any of my colleagues been here? Martin Perpich or anyone else from Red Hat Product Security? Talk to you guys?
No. But also, just for the context, what we've talked so far on this call, I think we have a couple of meetings when we went through the Trustify. So through the basic architecture and APIs, and we went through basic database schema and for SBOMs,
Right.
like packages, pearls, and things like that. So yeah.
Okay. Would it be useful, maybe I'll put a frame around it and then dive into the detail. Is that okay? And tell me if I'm talking too much or if I should dive into the detail quicker. It might be easier. Okay, great. Right. So Red Hat Product Security, this problem is something that we've solved many, many times over the years. I'm counting, I think RHTPA or Trustify is probably the 6th or 7th version attempt at solving this problem. Many years ago, it was just about software, transitive dependencies. But now we have other relationships. At Red Hat, with our SBOMs, we're interested in donating things like what's a product relationship to a bunch of components or packages or source to binary or image index to containers. So it's not just software transitive dependency relationships we're interested in. And the mistakes made in the past, I think, are a combination of people not really. Well, it takes a while to understand the peculiar, the peculiar data structures and endemic with security domain. But people start with what they know. So right, I'll use a SQL database and they'll shred a tree and they'll use some algorithm like, I don't know, MPTT or something to represent a graph structure using Postgres. And then they'll get join explosion and they'll be like, oh, this is painful and this doesn't work at scale. The most recent iteration that Product Security wrote was designed to have a graph database. And just as a little background, I worked on databases for 15 years at a company called MarkLogic, and we had a SQL document database, graph implementation, et cetera, and when that company was sold, my team, the core engineering team, basically went to AWS Neptune. So I really understand a lot of the pain with graph and this sort of multiple approaches. So the idea is that people would then use a graph database, and then they get sort of unpredictable performance because graph databases, well, they don't have 40 years of optimizations, and also you can create unpredictable performance with queries. You're basically stuffing all the smarts into one single index, the graph index. SQL sort of solves it by making more indexes. It's sort of a trade-off. You put the complexity into the graph, into the query, versus the complexity into creating indexes. So when I started the last version of this internally, I was thinking what would be good is to use the strengths of the multi-model. Use SQL, what SQL's good for, because there's a lot of sort of entity data. And don't try to stuff everything into a graph because you're going to end up with other problems. Represent tree data structures using graph because you want to ask it tree questions. Yeah. That failed because we just, at Product Security, we don't have many resources to work on stuff. And then we got Dayan's team and other engineers to actually do things properly. And then that's when I was sort of thrown into their team with Trustify. I didn't have much to do with the first version of Trustify, but the second version of Trustify sort of instantiates those principles of a hybrid approach, which is, once again, there's a lot of entity data that happily live in rectangles, and then let's represent the data that is amenable to graph in a graph. So once again, we looked at stuff like Postgres, Apache Age. We looked at other ways of shredding trees into Postgres. Postgres is great, but really we needed a native structure, and because we're writing in Rust, we had the opportunity to look at packages. So we chose. I did a survey and chose PetGraph because I thought the graph math underneath it was really good, and it had an efficient in-memory representation of data. So even if you had 1 million or 20 million components, you could represent them quite efficiently. So what we've done is we don't need a full-blown graph database. We don't need ACID transactions. We don't need long-term persistence, because we know every time we get an SBOM, we're never going to touch it again. So it's read-only. So that removes a lot of problems. Inserts on or delete of nodes in a graph database are costly. And the idea of going back, let's say you had a change in the Perl format and you want to change all the Perls in your graph database. It's actually cheaper to just regenerate the read-only graph instead of manipulate in memory a data structure. So sort of principle number one, read-only, no mutations. Principle number two is that normally most people are interested in the latest version of things. They don't really care about an SBOM from 20 years ago, though you might want to go do that. So we could have an MRU or some recently used concept, either based on the time dimension or size dimension. We only want to have 1 million SBOMs loaded at any point in time that are used, or et cetera, et cetera. And we'll put the other SBOMs on cold storage. So if you're interested in stuff, oh yes, sorry, Brendan, go ahead.
Oh yeah, complete your thought first, and then I'll ask the question. Yeah.
So the idea is that older stuff you can still query. It's just colder. It's not. It might be a different partition. Yeah, your question.
Yeah. I think I was thinking about this, right? Because we've ran into some of the issues that you've talked about, where like graphs are difficult to manage. Indexes get tricky. It's hard to deal with the graph structure itself. I think there are kind of two categories of use cases that is useful to think about in the graph structure. I think one of them seems to be what you're hinting at, which is at a consumption time, I'm going to retrieve all the necessary predicates, put it in a graph, and then do the analysis on the local cluster of things that I care about. And then there is kind of the other category of things where I want to do a global analysis of the data set and pick up clusters and certain trends. I think it sounds like what you're talking about was like the first use case, but I'm also curious to hear what you think of the second use case.
It's a great point. So the operational graph, the operational pet graph, if you want to do historical or analytics on it, that's not really the place to do it. But there's nothing stopping you hiving off and spitting out triples into a real graph, right? And that's my sort of plan there, is that to separate the modes of separate runtime operation versus something else. And the something else would be, AWS Neptune. I have a connector to that, so and it might not get updated as quickly, but we can store terabytes and terabytes of stuff in there. There are other options. The guys who did Redis Graph have created a nice new plugin for Redis called FalcoDB. I don't know if you know them. But that has good math and it's very stable. It's built on very rock solid stuff. So there's very few, having been in creating and writing databases, one of the things that was the death knell of open source graph databases was the inclusion of it in SQL. So, now you have property graphs in SQL. So a lot of people lost motivation to implement because it's just going to show up in Postgres anyways at some point. And really there's sort of upper end, where I worked at before, people were using very large graphs indeed. A lot of government agencies, a lot of, Obamacare, for example, MarkLogic was the database under that after Oracle. Well, I won't say they failed, but there were some problems with it. And they used a lot of graph. And those kind of scales, it's just a different one-off beast. It's like the problems that Google and Red Hat have are kind of unique because we're interested in all ecosystems and all of it, and we're interested in before we release. So it's not just about the release SBOMs, but it's also all the SBOMs sloughing off all the build systems, and we want to do we operations on that. So from a Red Hat point of view, we separate the loads. So we have an instance dealing with builds, and we have an instance dealing with releases, and that's for customer consumption downstream. So yeah, I wouldn't want to try to double up on the operational graph to do all things. I think what we've got to is something that we know we can run and we know we can care for, and it seems to it can scale up, and we know how to horizontally scale it in terms of in our architecture we're using OpenShift, and we know that we can we represent each. There are lots of ways to have different namespaces and different graphs. We don't use RDF, obviously, it's a property graph. So what we've chosen is just simple memory structure, a hash map of graphs, each graph being an SBOM. And the idea is that, the only time we have to look at another graph from a graph is if it has an external reference. So it's easy for us to recurse through that kind of situation. If that's the case, then we can have a global instance of part of that graph on many pods that we can sort of query all at once. So we have horizontal scalability from a runtime, but all the analytics stuff, all the sort of other stuff hanging off of it, my plan is just to shift triples off the system into a proper graph database. And then that way, a lot of times, I don't know if it happens with folks here, but a lot of times, people have their own operational metadata needs. And one of the problems with graphs is you just start stuffing it, and it's an uncontrolled schema where people just keep on adding, nodes of information to everything. And this can lead to chaos. You need to have some, using a graph database doesn't mean no schema. It means you have to take on board a little bit of work with ontology and taxonomy. And sometimes it's kind of safer just to isolate things. Here's a product graph. Here's a, don't overcomplicate any single graph, because the queries will become hard to understand and also probably hard to test. So where are we at now? So the testing, at the moment, we're at like the old system has something like 10 million SBOMs in it. And it probably has about 20 or 30 million components from those SBOMs. There's some small SBOMs, really tiny ones, some big ones like I don't know, OpenShift or RHEL. They'll have 50 or 60,000 packages in each one of them. And those are the kind of numbers we have. And that old system, based on Postgres, is about a terabyte and a half. That's after running for 2 years. So I expect the same kind of numbers operationally with Trustify, and I've done that. I've generated synthetic data, and things look horizontal to me in terms of how we've split the hybrid model. One of the problems, I guess, one of the things we encountered was multiple pearls. How we can represent, a single component can have multiple pearls, and that's an interesting thing, because if you decide at the beginning that only one thing has a pearl, there's a problem. And then there's a problem with SBOMs in general, and that pearl is sort of an approximate identifier. a Perl is only concrete in the context of any particular SBOM. You know, if you have a Perl that says, I have curl here and I have curl here, and they have the same exact Perl, that doesn't mean they were built the same way in this SBOM. It might have been built differently. It's not the same bag of bits. So the context of multiple Perls and multiple SBOMs sort of needs to be teased out, you know, before you go and pour concrete onto your data models. And we've done that. So I think explaining all the decisions of why something lives in the graph or why something lives in the relational database, I think the rule of thumb is, once again, if you have tree questions, then it should live in the graph. And once you know, that's software transitive dependencies. That's things like we want to know our upstream, you know, to our stuff. We want to know our source binary relationships. You know, in Red Hat, we generate a bunch of SBOMs where we'll have a source, and then it'll generate all the architectures, you know, all the different binaries, and then the image index in containers. And there'll be more. You know, Golang is fun, so we'd like to get a bit richer representation of what's happening there. Middleware, that is Java, is pretty straightforward and simple for us. You know, I'm curious how you guys have handled circular dependencies. Circular dependencies can happen in life, in the software, but the specs don't really constrain to the circular dependencies that are real. They allow all sorts of circular dependencies, lots of pathological, and now, you know, with external SBOMs, you can even have more versions of the pathological variety of circular dependencies. So that's I think that's probably one of our challenges. The other challenge is sort of, you know, operationally, we have a multiple truth approach. In other words, we get a lot of data from everywhere, but whose truth do you want? Yeah, well, who really knows? This person said this is the supplier, or this person is the organization. It might be ever so, you know, at scale, you always have error in data, and we want to at least be able to get to make the provenance of it very clear. Not make a decision of who's more, you know, trust OSV versus trust MITRE or trust NVD. It's not. It's sort of, you know, we need to sort of normalize on the multiple truths. That's sort of a big challenge. You know, and it's interesting for us because you know, if you know, curl, if it's built at Red Hat, doesn't light up a code path that's exploitable versus the rest of the world, and it's exploitable. You know, that's different severity for community versus Red Hat, and often we need to be yeah, metadata's opinion, not fact. That's perfect. Yeah. And dealing with that multiple truth is constant. You know, every time you add a new collector to something, like even something innocent like licenses, clearly licensed, for example, you have to think about it because nothing has a one-to-one relationship.
I'm curious on that point because I think, you know, thought a little bit about this, and I think initially our philosophy around this was like, okay, let's provide the information, where at consumption time someone can implement a policy to decide what they want. But I'm not sure whether this is something that's at least at the moment folks are able to do.
There's also, you know, like we as at Red Hat Product Security, sometimes we have to tell people what to do. Yeah, we have to sort of lead them and make their opinion, like decide their opinion for them.
It's a challenging usability problem, I think.
Yeah, completely agree. And I don't claim, well, you know, I don't know. I think the first step is capture all truths perfectly and correctly, and know where they came from and know the provenance, and then start slowly building up how people might want to navigate that. And I like the idea of profiles because, you know, you know, that the use case of Trustify, you know, we're sort of customer zero product security for Trustify. But if you talk about the generic use case, it's going to be different. You know, most people aren't Red Hat, most people aren't Google. You know, you're not going to want everything. You might just be a Windows shop or a Java shop, and you're just getting a small slice of data, and you might want to really customize it. I kind of feel like ecosystems is one of the dimensions that might emerge in terms of how you want to view on the data. Often internally at Red Hat, our teams are aligned on, you know, are people familiar with the underlying technologies? It's not one person hopping across all of them. And they're working in their little area. So I kind of feel like something like Trustify should have views based on users, you know, and that kind of starts off with, you know, what are you interested in if you're a C programmer or Golang or whatever.
I guess I have a question around what you've found, at least from a user perspective, folks that are using the data. What has been the most successful in terms of how they interact with the data?
Yeah. See, usually users only talk to you when they have a problem. Yeah. And the problems, you know, I'm sure you work at Google, right? So the problems are false positives and explaining those false positives, right? And so if you don't have the provenance of how you came to this decision, then or you just have a field that says you're not affected versus affected, you know, you're just, people are going to run their scanners and then they're going to get a hit and then you're going to have to explain it. So I think that is pretty much, well, you know, the transparency and the provenance part of the puzzle is huge, because now instead of support escalations happening and then, you know, some senior executive says, how are we not affected? You know what I mean? Now we can just point them to the passive data and they can answer the question themselves. Well, I'm hoping that's the plan. And when this system, we haven't made this last version of the system live for us, but yeah.
Yeah, I think that's exactly like the same issue that we have, and Marco and Nicole are also working on, like, so-called, at least for dependency and like, am I affected by something, like the notion of like SBOM quality, to say that, okay, we, like, SBOMs have varied amount of trustworthiness. And
Yeah.
so I think, like, one, like, if it came from, like, we have a Gradle plugin for SPDX, right? So if it was like SBOM created from the Gradle plugin, the reliability is going to be much higher than like you had SBOM that was generated by a container image scan, which has a Rust binary in it, which was stripped of metadata. Yeah.
Yeah, once again, I'm an old guy. I worked on lots of specs, and I find a lot of the security specs are really uncontained, where they should have been much more not as open-ended. It feels like kind of that there was this. I think it's not. It's got to. There's more maturing to happen to find to sort of localize and centralize on the use cases that matter. I think this is reflected in the tooling. You know, there's a lot of tools out there that generate SBOMs, and they have a lot of different opinions and a lot of different ways. And the idea that we're gonna sort of figure out what each one means and represent that consistently in a single layer. And that's what Trustify does a really good job at, in terms of, you know, we can ingest Cyclone DX, we can ingest SPDX, and we create a meta layer, a unifying layer across that. But there's still matters, there's semantic matters of usage of SBOMs, and we're just not there yet. I think the more people use it, and the more people say, you know, oh, you've used this tool to generate this, like, don't do that, you know, or that, you know, maybe that tool will get fixed. You know, in an internal sense, we have a curated, you know, we are generating the SBOM, so it's sort of an easier version of the problem. Trustify as for a general user, I mean, it's a little bit confusing. you know, is an engineer going to run this on their laptop and they're going to just connect up and maybe scan their own SBOMs? I don't know. It kind of feels like always an enterprise aspect to it. And that gets, you know, how people use SBOMs. I mean, some people are using, you know, external SBOMs as a way of organizing their compositions. And just that one decision can have a real impact on anything you do at a layer like Trustify. You know what I mean? You have to sort of, you know, there's no, the solutions are sort of more practical than they are sort of comprehensive. So where are we at? At the moment, we're pushing for 2.0.0 release. We've committed to a date internally, and there will be a date of release because in Red Hat engineering we don't give out dates. I'm not going to say any dates, but we're close, I guess, is the word. And right now with Trustify, you know, you can go to the site and pick up main branch and run it, you know, if you want to, and take a look at it. It's pretty easy to run. You know, it's Rust, so you'll probably have to install the Rust stuff and say cargo run or whatever. And they're you know, if anyone's interested in sort of having one of us walk it through with anyone, you know, feel free. Be happy to get it installed on your whatever and show you how it works.
We've been to, I think, these basic, yeah, on the first meeting on how to run things and things. But yeah, we can do it again. No worries. So just to recap, like, so ingestion time, everything goes to the database. Some things go to the graph, and some then consuming APIs are querying database. Some are querying the graph, right? That's the philosophy at the moment, right?
Yeah, I think in Trustify we probably could move some of the things that we're still querying the database to the graph. Like we haven't fully gotten everything that should be graph yet, but yeah, and it lies down on, you know, it's like the differences are the type of queries. You know, if you just have a simple flat query against a flat list, it's in a database, then query it there. If it's a query that requires you to know, you know, the root of the tree or some relationship between two nodes in a tree or relationships between two different trees, then, you know, obviously you can do it in the graph. Yes, Parth?
Yeah, I mean that's kind of the question I had is like, when do you decide like which of the queries are you deciding to go from, you know, from Postgres to the graph? Like, is it like if I need to do the dependency, you know, some kind of a tree walking, all that kind of stuff, or?
Yeah, usually the tree walking is telling you important things like you know, if I was well, I'm trying to come up with a canonical use case. So basically, to get a list of all the packages, we have that as a table, obviously, and just getting that sort of normalized list is easy to pull from the SQL. But if you want to rehydrate all the relationships, the read only graph always derives from the Postgres, so there's no delta between the two. Yeah. The only thing is that in a security setting, you're always interested in asking two kinds of questions. Well, if you're a customer, you want to know what products are affected. If you're an engineer, you want to know what to fix. So sometimes you have one or the other. So given the situation where I have a piece of software, or let's say I have curl or I have OpenSSL, and it has a bug in it. I want to know everywhere where OpenSSL is affected. doing that query in relational sense is a join explosion, waiting to happen. So we do that in the graph. And what that does is it'll do a recursive query across all the graphs, asking, is OpenSSL in here? And often you don't want to know about OpenSSL. Oh, OpenSSL exists in this SBOM, but actually you have to tell the engineer to fix the source package, which might be really high up, or fix. And not only that, I want to know all the images, the container images that have this package. So you're always dealing with those kind of queries with the graph. The other way around is, I have a CVE or a vulnerability. Can you please, scan my products, which might be represented by a bunch of SBOMs? That actually is quite easy to query the relational database, because it's just a binary flag, yes or no. But if you want to say yes, and here it is in the tree, then it's the graph.
The graphs are all local graphs, right? There isn't a global graph.
Okay, so there's a global hash map of graphs that can span multiple pods, multiple machines, multiple whatever. That global hash map, each item in the array or the hash map is like an SBOM, right? That's how we manage it, right? We don't try to build a giant tree, because that's the way to madness. That's because I've done a lot of graph databases, and I kind of know if you want to sort of match it to the right grain, and that, to me, SBOM seems to be the right grain for this kind of problem. Because you're always asking questions. What's the SBOM container? We're not making assumptions that an SBOM equals a product. A product could be multiple SBOMs. A product could be multiple SBOMs that are inherited as well. It's not just about a direct relationship. A set of SBOMs equals one thing. It could be some inheritance upstream. An SBOM you don't know yet, so it could be partial knowledge. You might have a partial query and a partial response that might eventually get answered when you have that knowledge.
I'm kind of wondering, right? Because I think sorry, Paf, do you want to say something?
No, I was just thinking. So if there are separate graphs for each SBOM, then can you tie them together? So like, I guess you can, right? Because you can just be like, okay, then jump over to this other graph, I guess.
Oh yeah.
Based on
So we've implemented the in both SPDX and CDX, you have sort of external references. In SPDX you have external doc references, and then you have what is it? The bomb ref. Is it bomb ref in CDX? Yeah. So you can refer. And when the REST API is sort of the conceptual model, and that the REST API, if you've asked for a graph and it spans multiple SBOMs, it'll consult all those graphs, and then the REST API just constructs a bigger graph, right? Based on what you've called it all. And having each graph individually, you could have the process can be in parallel as well, so it's efficient. It's not. It can be made faster, and you're not just serially having to go through everything.
Yeah, I think that the question that we kind of always come back, and this is kind of like along what Pav was saying, right? Is like we always end up with this situation where, what's the benefit of putting all this in a central database versus like running it as a CLI tool on a single SBOM, right?
Yeah, being old database guy, like something should be in a database. That doesn't mean everything, right? Do you need atomic transactions? No. If you don't, do you need anything? In my mind, the question between a full-blown graph database versus just an in-memory representation was a bit of a revelation for me in terms of operations. It was definitely the right way to go. That was a surprise to me, only because I was ready to do the full-blown graph thing on AWS Neptune. I was sort of gearing up, and then obviously, Rust is is fast, so you can do these things. Yeah, quietly, very surprised, and it's very speedy at scale. It's instant, basically. Well, that's because you're referring to an index. You're referring to the graph index, which is instant. So there's no sort of performance problems.
Yeah, I think one of the things so we're also looking to kind of try and tie the SBOMs to like other build provenance, like salsa attestations and other things.
Yeah.
Unfortunately, there isn't a clear reference that we can say like, okay, this is the key. It's kind of like fuzzy still, and like the fuzzy things are also like opinion, not fact.
Yeah, it's another version of the same problem. Yeah, it smells the same. We're doing like we want to inject attestations at all points. Wouldn't it be great if our engineers ran a scanner, and that was a cryptographic attestation that we could ship with the SBOM. So when you don't have to run that scanner now because we've done it, or if you've run it and you can match it up and say, all right, that's great. They know about it. It's a powerful thing. But the reality of attestations, you got to be in control of the generation of SBOMs. I think that we're going to do it at Red Hat, definitely. But I'm skeptical of it as a general. Every tool is doing it, and I think it's going to be a bit chaotic.
Just one note on value of databases. So I think we still need them. At least that was our experience, like with GUAC in version 1, and then not having a proper database. We kind of missed a lot of place where we can store and search other metadata like CV descriptions and scores and everything. And you want to be able to provide API or UI to be easily to find these kind of
It's a continuum as well. Like you can start off that way, but eventually you might want access control. Eventually you might want a whole suite of things that will be hard to bolt on, and it's just there by default in your modern database. When to pull the trigger on that? Well, I'm pretty happy that the sort of path of pet graph in memory to a real graph database is there, because we might need that. Yeah, but we don't need we don't need ACID. We don't need to persist these things. Maybe in disaster recovery, we might want some form of persistence so we can recover faster instead of having to re-ingest everything. Maybe, don't know.
Yeah,
Even then, the re-ingestion would be relatively quick, right? It shouldn't be a big issue if you're in memory.
Well, I'm sorry, don't mean re-ingest from raw SBOM.
Okay.
We'll have backups of the Postgres database, so it'll be recover Postgres and then press a button, and all our graphs lazily load. So when we could say when you ingest it, create a graph, or we could say only when someone has requested it the first time, then it goes in. But yeah, we still have all the DR stuff we need through Postgres. It's just we don't have instant recovery, but it's not. It's much faster than re-ingesting all the SBOMs. Yeah, definitely.
Yeah, we have for the Google stuff, it gets a bit tricky because very quickly things don't fit in memory.
Yeah.
We are starting to look at maybe just to have like kind of like a Apache being like map reducing, just to figure out like how is this, like, is this identifier or this subject related to this subject, and maybe like that will help filter down the graph enough to be able to fit it in memory.
Well, I mean, you don't. I mean, I'd be surprised if you had any one SBOM that is gigantic. I mean, I had some pathological SBOMs of I don't know 250 megabytes. That's probably I haven't seen gigabyte size ones yet. But in general, I think the SBOM, like what are you representing with an SBOM? I mean, rel is about 80 or 90 megabytes. OpenShift is about, I don't know, all these things compress down. But what's the point? The point is that, you know, eventually you're going to have to span more than one pod. Yeah. So what's your approach to it is the only question.
Yeah, I think the issue we are kind of looking at is like the build provenance graph, not so much the SFON graph.
Right.
And
that'll be more active, I guess, than your release. Yeah, and you'll have that's the same with us. I mean, it's about 10 to 1, you know, difference. And I mean, in terms of, as long as I know I can just add another box to get more graph and horizontal, no impact on. I mean, I say no impact. It's a horizontal impact on performance. You know, if I have, you know, and I can't predict us having to run, you know, like 100 boxes. Like for us, you know, at worst I would say, you know, 5 to 10 pods to represent all this stuff. That seems quite tractable. For Google, it might be, you know, another 100. You know, that seems like you might want to approach how you scale, you know, differently. For us, it's very simple.
I just realized we're over time, but this was a good discussion.
So, real quick before we end, is this Trustification or Trustify? I see two.
This is Trustify.
Okay.
Yeah, a little bit confusing. 200 is Trustify. Trustification is the 100 branch.
I see. Okay. Yeah, I
Two
saw two
different
projects.
things,
I was like,
yeah.
I wasn't sure if that. I was like, is it the same or different? Okay.
Let me just leave the link. And yeah, we, you know, before we do release, we got a lot of tidy up in terms of docs and that README page and various other things. Yeah.
We will not tidy up docs because we don't have that much docs, but that's another story. Yeah.
We're being recorded, so you know, I'm just paying lip service to the idea, the aspiration of docs.
Yeah.